In the previous video, we took a look at diagnostics. This included going online with the PLC and reading the diagnostics information from it and the other devices. In this video, we're going to focus on the diagnostic tools built into Portal. And the first one I want to show you is the one that you'll probably use most often, and that's going to be monitoring your code. So to monitor your code, all you need to do is select any of your logic here in the project tree, open it up, and then up here in the upper right hand corner we have this icon with the glasses and the play symbol. Click on that and that will allow you to monitor your code. If you are offline like I was, it will automatically take you online and then take you to the monitoring view. You will know if you're monitoring code because the left power rail will be green if you're actively monitoring what's going on. If this power rail is black, that means that you're either not monitoring or you tried to monitor and there's an inconsistency between the offline code and the online code, which will prevent you from actually monitoring. Finally, if this power rail is a gray or light gray color, that means that this block is not being called at all anywhere in your code. So let's take a look. If we were to make a change here, if I flip this contact around, you'll see it automatically takes me out of the monitoring mode and I get presented with the inconsistency symbol here for that block. So to fix this, I can download my changes to the PLC and then I can monitor again, or I can just click undo to take it back to where it was. Now if I want to modify my tags, I can do so here in the monitoring view by either right-clicking on the element that they rest on or right-clicking on the tag name itself. So I right-click, say modify, and I can say modify this to be true, and you'll see that the state of my rung changes. And again, if I want to make it false, it's the same procedure. So that is it for the binary values. If I have an actual number that I want to change, again, it's the same procedure. I can right-click on the tag name, go to modify, and then hit modify operand. So here, I'll change this 10 to, let's say, an 11, and hit OK. And you'll see that it changes here, and also the output of my function changes with that. Now, if you would like to change multiple tags simultaneously, the most efficient way to do that is going to be through what's called the watch table. So here in your project tree, go ahead and you can add in a new watch table. And if I open this up in split screen mode, what I can do is I can just drag tags over from my code and drop it over into my watch table. So I can drag it like this. I can browse for them using the details view over in my project tree. Also, I can just come right here and just type in the name. So here I know I'll have my PB or push button that I want to add there. Okay, so now I have a few tags. I can monitor these directly from the tag table, so I can have an overview of the tags that are most important to me right in one screen. And if I want to modify, say, these two tags at the same time, I can do so by going to modify value, giving it a new value, and I can do this for each one. I want to be make sure that I have what I do want to change checked over here on the right, and then when I'm ready to go, I can hit this little lightning bolt symbol, and then they change. And you'll see that that change got reflected now in the code. Now let's say I wanted to change a physical input. So here I got my push button blue, and that is at address I33.1. Okay, so let's say I want to modify that to be true. I can just type in a 1 here for true, or type in true itself, and now I hit the lightning bolt. Okay, now notice that the value is still false. Okay, so what happened here was that it actually did go true for one cycle. But then when the cycle repeated, what happens is the PLC will read all its inputs again. And since the push button is actually not being pushed in, it read this as false and overwrote my modified value. So it's important to note that modifies can be changed in the code. You can modify a value to be true, and then if somewhere else in the code it gets overwritten to be false, it will happen. In order to get around that, we need to do what's called a force, and that's going to involve using a force table. We'll go over that process in a few minutes, but first I want to concentrate a little bit more about the monitoring procedure. So I'll exit that, and back here within my code, I want to show that here we are calling functions and function blocks. In order to open up those, you can simply just right-click on it and say open in monitor, and now I'm going to open up that function in the monitoring view. Okay, I can hop back to my other block just by coming down here at the bottom and clicking on my main routine. And let's look here at function blocks. So for function blocks, if you remember on a previous video, I said that they have their own instance data blocks. For instance, here I have the same function block called boiler alarm, and I got one for my first boiler, and I got another one for my second boiler. So if I open and monitor one of these blocks, notice here I'm clicking on boiler 1, and I say open and monitor. It's going to take me to the data that's relevant for boiler 1. So if I scroll down here, I have this variable that tells me the last time an alarm occurred, and this one was back in 2012. Now, if I want to see how the other boiler is doing, I can click on this button here on the right, and that will allow me to change the instance data block I'm looking at. So come up here to instance data block, and here I know I'm on boiler 1, so I can select boiler 2 now, hit OK. And then if I come down here again at the bottom, you'll see that the time's different. For boiler 2, the last alarm occurred earlier today. Now, if I need a reminder of which instance data block I'm looking at, I can just look up here above my favorite instructions. So here it tells me what instance data block I'm on. Also, it's important to note that if you have multiple PLCs in the project, sometimes you can get mixed up on which PLC you're actually looking at. All that information can be found in the title bar above. So I can see I'm working within this project, within that PLC, and I am working within this function block. Now, it's important to know that I'm looking at this code which is relevant to a certain instance data block. If I want to just monitor the data block itself, that way I don't have to go search through the code to find my relevant data, I can just go back in my project tree and then find my data block for, say, these boilers. So if I want to see the data for boiler 2, I can double click on it, and there are my monitoring glasses. I can click on those, and I can see there that the last alarm time was today. And if I go to my boiler 1 and hit monitor, you'll see that it was back in 2012. And I can do this for instance data blocks and global data blocks, and the icon is all the same. And now with monitoring out of the way, I would like to talk about forcing. Forcing is the process in which I can hold the state of an input or an output to be what I want it to be. And despite what might be happening to that input or output in my code or physically to the sensor, it will remain at that one state. I want to emphasize that forcing your variables is a temporary solution. If you're running a machine that is actively having forces on it, well, you're running the machine in a way that it was not designed to be run. So, if you do have to resort to forcing an input or an output, make sure you have a plan in place to fix the underlying problem. Alright, so I'll get off my soapbox now, and let's show you how to force a variable. So, I'll go here in my main routine, and here on this network I have some inputs and an output. In order to force these values to be true or false, what I need to do is I need to open what's called a force table. To do that, I'll go in my project tree, and near my watch tables I have this, my one force table. So I can double click on him, and then I'll open this up into split screen mode. Okay, so if I want to force this value to be true, this input to be true, I'll just take them from my code, drag them over to my watch table, and then to make that now be true, I can put a 1 here, and notice that the check mark will come in automatically. This is to confirm that you do want to change this value. If this is not checked, then the value won't change. So right now I have no forces enabled. If I want to enable my forces, I can hit this icon with the F and the play button and confirm by hitting yes. You'll see that anytime that variable is being used in my code, you'll see I have a little F symbol above it to indicate that this value is being forced. Also, when I enabled my force, the maintenance light on my PLC turned amber, and that means that I can walk up to a PLC, and if I see that maintenance light is on, I know that there are forces active. Now if I want to stop forcing all my values, I can do so by clicking on the icon with the F and then the stop symbol, pressing it, and then saying OK. And then you'll see that the force indication is removed from my tags that were previously forced. Also, the maintenance light on my PLC turns off. Now, one final word of advice, when it comes to your PLC code, if you are unsure about how a certain function is to behave, you can, let's say, here I'll click on this off delay timer. What I can do is I can click on it and then press F1. Okay, that's going to load up the help system, but it's also going to load it for that particular function. So here, if I scroll down at the bottom, I can get definitions of what the input and output parameters mean, and I can get examples of how this function is supposed to behave. It's important to note that this feature is available for all the Siemens instructions found within the TIA portal. Okay, next with PLC programming out of the way, let's look at tracing. So tracing is the ability where I can visually see the state of my tags over time. So to start a trace, I can click here on Add New Trace, and then open up the trace file that it made for me. And now what I can do is I can add in signals or tags. So if I go back into split screen mode, I can drag in some tags from my project. So I'll add in the push button, and I'll add in my 2 potentiometers. And now if I want to see what they're doing over time, I can do that here. First though is I need to select what kind of sampling I want to do. So what's maybe different about our approach to traces is that it's done according to the cycle of the PLC. So by default, it's going to be set up to run with OB1, your main routine. And as we know, the main routine, it's not a deterministic cycle that the time can change depending on what it's doing. So here I will tell it I want it to record every cycle of OB1, and I'll do it for the max recording duration, which will be over 58,000 cycles. If I wanted to put it to a different OB, for instance, if I click on this button here, I made an OB called cyclic interrupt trace. If I click on that, that is actually running at a predefined time. So when I click down here, I can see what that time is. 1 cycle equals 1/100th of a second in this example. If I wanted to record every 1 second, I would make this record every equal 100 instead of 1. Then when I click away from that, you'll see that this gets updated, that this will run every 1 second, and the max duration is going to be this humongous time, and this equals hours. So I'm going to switch back into the main routine, and typically you'll just trace according to the main routine, and recording for 1 cycle is fine. So let's see what this looks like with the signals I selected here. To do that, I need to download it to the PLC and enable tracing by hitting yes. Now it's important that this trace is not being done by my computer. This trace is actually being done by the PLC, which is great. That means that you don't have to worry about aliasing or resolution problems. The PLC will pick up every event because it does it cycle by cycle. To start my trace, I hit the record button up here, and then I can see the status of my signals. So here at the bottom, I'm pushing my green push button in, and over at the top I have my potentiometer signals, and I'm spinning them around. And you can see their status change over time. To stop the trace, I can hit my stop button here, and now I'll get the picture of all their status values over time. I have a bunch of different features up here, such as zooming and panning. I can do automatic scaling, or I can arrange all my signals in tracks. That way I have a designated area for each signal that I am tracing. Typically we'll break this up into 2 windows. Your discrete or binary values will be here at the bottom, and your numerical tags will be here at the top. Now, if this recording is important to me, then I would want to save it. To do so, if you go in the project tree, you'll see that we have this folder called measurements, and currently there's nothing in it. So what I want to do is I want to click on this button here and add it to my measurements. So when I do that, you'll see that the trace is now here, and now I have a hard recording of what that trace was when I took it, and then I can come back here at any time and review it. I can also export this as a CSV file by clicking on this button up here, and then down here at the bottom where it says Save Type As, I can select CSV. So by doing that, now I can open up the data in Excel and do my data analysis or send it off to someone else in an Excel format. I can also right-click on the diagram and I can copy the image to the clipboard and then paste it into a report or an email. A very nice feature within tracing is that I have the ability to set up what's known as a trigger. So what a trigger does is it makes it so that the PLC will only record whatever signals I select when a certain event occurs. So this would be if a tag changes state, or if a tag rises or falls to a range in which I'd want to see the values of these signals. I can set that up. And again, because this is being recorded by the PLC and not by my PC, that means that I can set up a trigger, walk away with my computer, and the PLC will sit there waiting for that event to occur. And if it does, it will record all the signals that are important for that event. So to set this up, what you can do is you can select Trigger on Tag, and then you'll select your tag here. So what I like doing is if there's a diagnostics event, like a fault occurred, what I like using is in your system bits for your PLC. And that is a tag that will tell you if there's a change in diagnostic state. So if I go down here to my PLC and select system and clock memory, and if I have this enabled, I have this tag I can use called diagnostic status update. Now, this is a tag that will go true anytime the diagnostic state changes. So if the PLC goes from a good state to a bad state or a bad state to a good state, then this will go true. Now, it will only go true for one cycle of the main routine. So if you are going to use this as a trigger, make sure that you're setting this up to run every cycle of OB1. Otherwise, you'll need to make a little rung in your OB1 routine like I did here, where I can stretch out that signal with an off delay timer. Okay, so to add that tag over to my trace, I can just come into my trace and I say trigger on tag, and then my trigger tag will be my diagnostic status update. Once I have that selected, I can select what type of event, so I can say when that turns true, or if that goes false, or on the rising or falling edge, or just if the value changes at all, I can select that here in event. So here I'll keep that as true. And then I also got this other great feature called pre-trigger. So what I can do is I can set up X number of samples before the event occurs that the PLC will actually record that. The PLC does that because the PLC is always keeping a moving window of what previously happened to it. So if I set this up, and let's say I set up for 1,000 samples, that means 1,000 samples before the event occurs, I'll be able to see what happened, which led up to the fault. So that's very useful. Once I got all of this set up, then I can download it to the PLC, and I can just overwrite what I put in before and enable my tracing. Okay. Now it's very important here that I hit the record button, and here it's going to say waiting for trigger. Now, what I can do is I can close out my trace, and I could even close out TIA portal, it doesn't matter, because now that trace is loaded in the PLC, and the PLC is actively looking for that fault to occur. So I'm going to go ahead and create a fault. I'm going to turn up one of my potentiometers so high that it causes an overflow fault, and you'll see that I get the fault icon here. I'll turn it back down, and you'll see that everything is good. To check the results from my trace, what I can do is come down here on the project tree and then open up my trace. And you can see here it's compiling what it recorded. If you don't see your trace file here, you can click on this upload button, and that will bring in whatever trace configuration has been stored in the PLC along with the trace that it recorded. So now I can see how the event occurred. So I can see that my pot 2 went from this low value and went up and up until it hit this overflow limit. and then this is where I turned it back down again. You might notice that pot 1's doing something. It's not actually going from 35,000 up to 50. You have to click on the signal here, and you can see the scale that it went from 8 to 7, which is just a little bit of noise. Important to note with tracing is that you can trace up to 16 signals in one trace, and you can also have 4 consecutive traces or simultaneous traces going on at the same time. So you can have up to 64 signals that you're tracing, which is makes it a very powerful tracing tool. So we'll pause the video here. In the next video, we're going to continue our discussion on the diagnostic tools. We're going to be taking a look at cross-references, and we're also going to be taking a look at the additional PLC diagnostic tools built in the TIA portal.